Hello. Today we are going to talk about linear and nonlinear functions, and we already know that the vocabulary word of linear means straight line, so therefore nonlinear would not be a straight line. We can investigate a constant rate of change to determine if it's linear or not. It says the U.S. Department of Agriculture defines a heavy rain as a rain that falls at a rate of 1.5 centimeters per hour. The table shows that the total amount of rain that falls in various amounts of time during a heavy rain. We're going to complete the table, and then we're going to plot the points on our coordinate plane. So our first one, we notice that at 0 hours, we have 0 rainfall, and that makes sense, right? Because no time has passed. And then after an hour, we had 1.5 centimeters of rainfall. At 2 hours, we're going to expect to have 3 centimeters. At 3 hours, we're going to expect to have 4.5 centimeters. At 4 hours, we expect to have 6 centimeters. And at 5 hours, we expect to have 7.5 centimeters of rainfall. What I was doing is I was taking this information that the rate was 1.5 centimeters per hour, so 1.5 times the number of hours, and that's going to give me my rate of rainfall, or the amount of rain to expect. So now I'm going to take this information, these ordered pairs, and I'm going to plot them in this graph. So my first one is 0, 0, and then 1, 1.5, 2 at 3, 3 at 4.5, 4 at 6, and 5 at 7.5. And if I were to draw a line through this graph, I see that all the points sit on a straight line, so I know it's linear. They want to know about how much rain falls in 3.5 hours. So I can take what I did here and multiply it. So 1.5 times 3.5. And when I do so, I get 5 and 25 hundredths of centimeters of rain. So 5 and 25 centimeters of rain. And then they want us to plot that point on our graph. So if I came over here at 3.5 and went up, it would be just a little above the 5 mark. What did we notice about the points? They did create a straight line, didn't they? Okay, so they created a straight line. So when we connect those dots, we've had a straight line. Is the total amount of rain that falls a function of the number of hours that the rain has been falling? So is this a function? Yes or no? Okay, I agree, yes. And why? Because if I did a vertical line test on this, each input has exactly one output. Okay. When we graph linear functions, says that the relationship you investigated in the previous activity can be represented by the equation y equals 1.5x, where x is the time and y is the total amount of rain. The graph of the relationship is a line, so it is a linear equation. Since there's exactly one value of y for each value of x, the relationship is a function. And so that's why we call this a linear function, because the graph is a non-vertical line. Okay, so it's non-vertical, which means it doesn't go just straight up and down. It creates a line, so it's linear. And when we do these vertical line tests on it, we find that each input has exactly one output, so that makes this a linear function. It says the temperature at dawn was 8 degrees Fahrenheit and increased steadily at 2 degrees Fahrenheit every hour. The equation y equals 2x plus 8 gives the temperature y after x number of hours. State whether the relationship between the time and the temperature is proportional or non-proportional, and then graph the function. So with what we already know about equations, y equals 2x plus 8, just looking at the equation, is this proportional or non-proportional? If you said non-proportional, you're correct, because there is a y-intercept, and this is what makes it non-proportional. So it is non-proportional. Can it be non-proportional in a function? That's what we're going to find out. So it says compare the equation with the general linear equation y equals mx plus b, and we see that the b is 8, that's our y-intercept, and therefore it is a linear equation, but it is non-proportional. We're going to choose several values for the input x and substitute these values for x in the equation to find the output y. So if x is 0, I'm going to place 0 in my equation. 2 times 0 is 0 plus 8 is 8. And so 8 is my output, and then my ordered pair is 0, 8. My input is 2. 2 times 2 is 4. 4 plus 8 is 12. My output is 12. My ordered pair is 2, 12. Okay? And then we're going to plot those, which is what they did here. There's 0, 8. There is 2, 12. 4, 16. And 6, 20. And we were able to connect those, and it creates a line, a straight line, so it is linear. And we know it is a function because if we did the vertical line test, each input has exactly one output. Okay? State whether this relationship between x and y in y equals 0.5x is proportional or non-proportional, and then graph the function. When I look at the equation, y equals 5/10 x, I notice that the only way I can have a y-intercept is if I add 0. So that means this is proportional. It has a proportional relationship. And if I were to find some ordered pairs, if I have x and then y, and then I have my ordered pair of x and y. If I have x is 0, 0.5 times 0 is 0. So my ordered pair is 0, 0. If it is 1, 0.5 times 1 is 0.5. If it's 2, I take my 5/10 times 2, and that gives me 1. And if I do it again one more time with 4, I take 5/10 times 4, I'm going to get 2. My ordered pair is 2. Let's graph some of these. I have my 0, 0. These are going up by 2, so let's go down to this next one. 0, 1, 0. Oh, just realized I made an error on all these. So I had 1 and 5/10. I had 2 and 1, and I had 4 and 2. There, fix those. So I have 1 and half. I have 2 and 1. It's really hard to do that 1/2. So 2 and 1 and 4 and 2. And if I were to continue, I would find that I have a straight line. So this is a linear function. We just did that, so let's do another example. It says a square tile is a side length of x inches. The equation y equals x squared gives the area of the tile in square inches. determining whether the relationship between x and y is linear, and if so, is it proportional. So we're going to choose several values for the input x, and we're going to substitute them into the equation and find the output. So if x is 1, 1 squared is 1, so my ordered pair would be 1, 1. If x is 2, 2 squared is 4, so my ordered pair is 2, 4. And we just kept going. Then I'm going to graph these. 1, 1 will be about here. 2, 4. 2, 4 is here. 3, 9. And 4, 16. And now if I were to try to draw a line between all those points, what do we notice? It is not a straight line. It actually has a curve to it. So because it's not a straight line, it is nonlinear. Is it still a function? If I do my vertical line test, is it still a function? Yes. So it is a nonlinear function. And because it's nonlinear, it is non-proportional. Let's take a look at this one. A soda machine makes 2/3 of a gallon of soda every minute. The total amount of y that the machine makes in x number of minutes is given by the equation y equals 2/3 x. Determine whether the relationship between x and y is linear, and if so, is it proportional? So when I take and substitute my values in for x, so I have 2/3 x at 2/3 times 0, I get 0. At 2/3 times 3, I can cross simplify. 2 times 1 is 2, so 3 is going to be 2. And if I take 2/3 times 9, cross simplify where I can. 2 times 3 is 6. So now I need to figure out what I'm doing here. So now I'm going to take a look at a pattern. I'm adding 2, adding 2, adding 2. So these were all plus 2's. Plus 3. What could I add 3 to get 9? That would be 6. Okay. So now I have my ordered pairs 0, 0, 3, 2, 3, 2, 6, 4, and 9, 6. Are we able to draw a line through them? Yes. So, because I could draw the line through them, is this linear or nonlinear? Is it a function? And is it proportional or non-proportional? So it is a straight line, so it's linear. If I did a vertical line test, I have one output for each input, so it is a function. And it is going through the origin, a straight line, it is proportional. So this is a proportional linear function. If you have any questions, please make sure you see your teacher.